In this video tutorial, we're going to cover the Langmuir Systems tool setter. We're going to show you guys what comes in the kit. We'll show you how to get that mounted, how to configure its position on the table in the cut control software. Then we're going to walk through all of the various tool setting routines that are built into cut control. And we'll show you guys how to use those, and we'll show some examples of making some basic tool changes using the tool setter. So to just cover what comes in the kit, you'll notice that we've got our tool setter. It's already mounted to our base plate. And it's got a mounting flange here that has a position for 2 cap screws. These are 1/4 20 cap screws. They'll come in your kit. And the idea here is that these spacings will fit our base plate. They fit the grid. So depending on the project you're doing, you can move your tool setter really anywhere on the table as long as it'll fit. We find that a lot of times if we're doing any type of vise work where we're doing part flips and tool changes, really nice to have it just right next to it. That'll minimize the movement of the machine as it comes down and touches the tool setter. And we'll show you guys how to let the machine basically know where the tool setter is. We've got limit switches on this machine, so in a machine coordinate sense, we should always be able to tell it where this tool setter exists and then go find it in our tool setting routines. We're going to cover all that as this video goes on. A little bit too that you'll notice about this, I've already done this. I've already set this one up, but there are 4 set screws that basically hold the body of the tool setter inside of this stainless mount here. So there's 1, 2, 3, 4. And what these are for is there's wings on the base of this tool setter. And the idea here is that I want to get this platen level to the travel of my machine, which is essentially the level of this base plate. It's also the level that the machine will track. Easiest way to do this, you're going to take your indicator. If you've got a magnetic base for your indicator, you're going to want to just stick it right to the side of the spindle cover. And then the indicator tip, you're going to want to come and have it rest on the tool platen here. And then you're just going to, sweep in maybe the X direction, sweep in the Y direction, and you're going to make adjustments to these set screws to get the level of this planer to our level of travel. And the reason this is important is if I've got an angle to my tool setter and I come over and I touch a tool and it's touching off, potentially right here on one side versus over here, if this is 10 thousandths high, let's say, that's going to be a problem when we're really shooting for 1,000th or 2 of really precision between our tool changes. So it's really important to get that set right. Again, we've already kind of done that here. The other thing is going to be cable management. So you'll notice that we give you guys a lot of cable length on the tool setter. That's really to kind of get creative with how you guys want to manage the cable. The way that we have it set here is we've just found that running it along one side of the Y-axis rail, just kind of sitting here in this channel, is really nice to just let the cable kind of run through here and then out the grommet if you've got the enclosure, or just right off the edge of the chip tray if you do not. And so, as you move this thing around, you can just kind of figure out ways to manage the cabling. We've also seen folks use P-clamps in these screws. That's also kind of a creative way to get it to follow along here. That works really well. Another thing too, you're gonna wonder about this tool setter is, can you run it with flood coolant? Yes, you can. The tool setter is completely waterproof. You'll notice this boot that sits on here. That's keeping any water out of here. The way that this thing goes together, it's got O-ring seals and everything. It's got O-rings for these strain reliefs on the cable. It is fully waterproof. So feel free to go ahead and let the coolant fly on this. So once you've got your tool setter to a point where you've got it leveled, you've got your cable management, you've got the aviation connector on the end of this plug plugged into the electronics enclosure in the tool setter port, not the touch probe, tool setter, and that will matter for cut control. So once you have that set up, really the first thing to do is just come and press on the tool setter. You'll notice it's got some spring loading to it. And just make sure that the LEDs that are around here, those should be off in the rest condition. Shouldn't be seeing anything if it's plugged in. And to just test it, just go ahead and put a little pressure. You'll see those LEDs light up. That simulates that I am activating this in the down Z direction, which is how we touch tools off. And we'll show you guys what to look for in cut control to make sure that the communication between this and the control system is all working properly. And then we're going to get into doing our first routines. Thanks. Now that we've got our tool setter, we're mounted to the base here. We know that we're plugged in. We're seeing the indication lights when we push the platen down. Now it's time to get into cut control. And what we're going to do is, first thing I like to do is we're going to run this. Well, first of all, let's show you where the module is. So right below touch probe, it says tool setter, and it's got this little toggle. I'm going to expand that. So a couple of things you'll notice. One, it says tool setter location is needed. And that's because I haven't told it yet where my tool setter exists. So we're going to have to go and do that. The other thing is we have this test button. And if I turn this on, you'll notice it'll turn red. And I like to use this test button really before I do any of my tool setting. What that does is it just makes sure that I've got my tool setter and it's plugged into the right port over there. I don't have my touch probe and tool setter crossed. That'll cause problems. The other thing is just kind of a sanity check. You know, before I plunge my tools right down into this thing, I want to make sure that it's working. So what I'm going to do is push down on here with one finger, activate it, and I'm going to look for this LED status down here in cut control. You'll see that it now illuminates tool set when I'm pushing on it. When I let go, it goes to nothing. Push down and it's tool setting, let go and it's doing nothing. If you're activating the tool setter and you're not seeing that tool set when I've got the test, something is likely wrong. You know, feel free to go and do your own troubleshooting, check connections, things like that. If you have any other questions, you can reach out to our tech support. So once I get that out of the way, I know that my control system is communicating with the touch probe appropriately. Next thing I need to do is I need to tell the machine where this tool setter is on the table. Now, in order to do that, I have to home it. Because without homing it, it doesn't matter where this is or where I tell it that it is. It needs a reference point. And that reference point is going to be the home location. So I'm just going to go ahead and hit home here. It's going to go on home of the machine, which if you've made it this far, you've probably done this a number of times. So, you know, just want to reiterate that you will not be able to use the tool setter unless you've homed your machine. Next thing I'm going to do is I'm going to just bring it closer to my location. I'm just going to do a send to front move here. That's going to just bring it right in the center here. I use that mostly for tool changes when in between running programs. You can actually change the machine coordinate position of where the send to front button sends your spindle, but for now the stock position is pretty good. All right, so now what I'm really looking to do is I want to bring the center of my spindle, the axis, really as close as I can to the center of this platen. So to do that, I'm just simply going to jog it over the center, and we're going to let the machine know the machine coordinates that exists at this center point. Then in that sense, the machine will know where it is. So I'm just kind of rapiding close here, and then I'll probably pick some slower feed speed. 10 inches a minute works pretty good. And you know, I don't have to get this perfect, but the ultimate goal is really just to kind of get it visually over the center point here. You know, and I think that's probably pretty good. So then what we're going to do is we're going to go back to the tool setter module, and we're going to click the little settings button here. Again, it's already reminding me that tool setter location is needed. So I'm going to hit the settings button here. It's going to pop up the tool setter settings menu. And I have a couple options. I can go in here and I can just type in myself coordinates for where this is in machine coordinates. That's obviously too much work. So I'm just going to hit the set from current location. What that's going to do is it's going to feed in my current machine coordinate positions that the spindle is sitting at right now. And then after that, I'm going to hit the save button. All right, we know we did it right. I've got this menu unlocked. So now the machine knows where that tool setter platen is in 3D space. And we can now move on to the next step, which is calibrate. One thing that I really want to reiterate is if you guys move your tool setter location, you know, you're changing projects. We move this thing around all the time. I mentioned, you know, next to the vise is really helpful. If you have a fixture, you want to move it closer to that, really understandable. Just make sure that whenever you do that, you know, don't forget to change your, go in and basically redo the settings and tell it where the new position is. We've built in kind of a safeguard against that, and I'm going to show that in the next menu. whenever you click a calibrate or tool set, the machine is actually going to tell you how far it's going to move in X, Y, and Z before it goes down into the tool setter. That's kind of just an extra check to let you know that, kind of a sanity that says, oh, okay, I am in the right spot. So with that said, we're going to move on to the calibrate function. All right, so now that we're set up here, the next step is going to be to use the calibrate function in cut control. Now, in real simple terms, what we mean by calibrate is cut control needs to know the physical distance between my work coordinate Z0 and the surface of the tool setter. Again, that's whatever my surface is for Z0, whether that be the top of my part or the top of a piece of stock, that's my Z0 point. What we're going to do is we need to basically know the distance between that surface and the surface of this tool setter. Because if we know that distance, then we can make auto tool changes really fast. I can put a new tool in, I can hit auto tool set, it's going to touch off here, it knows the distance between this surface and my Z0, it's going to do the math automatically, and then now that tool is set to Z0, it's ready to run your part with the next cycle operation with that tool. So just to show you guys off camera, I already zeroed the surface, this end mill to here, which is my part surface. That's where my Z0 is here. And so I'm just going to come down to 0 to show you guys. So I'm at Z0 here. I'm in my G54 work coordinates in cut control. And now what I'm wanting to do is make a calibrate move on this tool setter. So all I need to do is come over to cut control, and I'm going to hit this calibrate button. Now before I do, I want to look at this tool offset value, because that distance I was talking about between the G54 0 plane and the tool setter, that is this offset value. And you'll see that I have none here. I haven't run the tool setter yet. There is no value. But I'm ready now. I'm going to hit the calibrate, and really important, I've got this toggle here. There's either tool or there's probe underneath the calibrate button. I'm using a tool to do the calibration. If you want to use the probe, we'll cover that in a later section of this video. That basically streamlines this process even faster. I can find the surface of that part and calibrate the tool setter together. It makes it just much quicker to do. But for this instance, I'm just going to calibrate using the tool. We do it very frequently. It's easy to do. So I'm going to hit the calibrate button. I'm going to get this pop-up. Like I mentioned, it's telling me the machine will make a rapid move about 11 inches to the right and about 11.5 inches forward. So just looking at here, that passes the gut check. I know I'm probably in the right move here. So I'm just going to hit continue. So it's going to move, rapid move over to where I told it the tool setter was. Now we're going to come down into our tool setting routine. It's going to come down fast, touch, retract, come down, and then softly find the surface, and then it will retract up the retract distance, which in my case in the settings is set to 1 inch by default. I'm going to get this calibration completed, and what I'm going to see here is that my tool offset value has been calculated now. I know that now the distance physically between this surface and the top of my part is exactly 1.287 inches in the negative direction, and that's really all you need to do to calibrate. Okay, so in the last section, I was able to perform the calibrate function in cut control. So I now know with my tool offset value, I know the distance between my Z0 plane here and the tool setter. And so what I'm going to do now is I'm just going to make a tool change. So I can use the send to front here. Just kind of, it's already kind of at the front, but I'll put it up a little higher for me, and I'm going to swap this tool out. I'm going to use a 1/4 inch 2-flute chamfer, and I'm going to do some engraving on this part. So let me just go ahead and swap this out. All right, so get my tool in there. All right. So now what I can do is, now that I have my calibration done, as long as I don't move my GZ0 and my G54Z0 and I don't move this tool setter, I can make as many auto tool sets as I want here. I can just pop a new tool in, hit the auto tool set button, boom, it's gonna set it for me. So let's go ahead and do one of these. I'll do an auto tool set, then we'll jog back over to the part. We'll go to Z0 and we'll show you guys that it's sitting right at that Z0 plane, doing exactly what it's supposed to do. So coming over to the tool setter module, all I'm gonna do is I'm gonna hit the auto tool set button. It's to the right of the calibrate, which we used before. I'm just gonna hit the auto tool set. It's gonna also confirm that my tool setter is in the right location. We've got pretty good confidence now. Hit continue, and it's gonna go and do a tool setting routine here. So probably could have saved time by manually jogging down first, but that's just the reality here. All right, so what should have done is I should get the auto tool set complete. I'm back into rapids here. So what I'm gonna do is just basically go back over to where I was, and we'll just do a visual check. We'll come down to Z0. Okay, I'm gonna hit go to Z0, move down a little bit so you can see in the DRO I'm at 0 and Z, and that tip is now right sitting on the exact top surface of that part, exactly what we want. So that's the basic process. I can then load my next program in, which is this engraving operation, and I've got to drill some holes after that. It's basically going to repeat the process. I'm going to put my drill in, hit auto tool set, it's going to go do its thing, load my program and start it. And that's pretty much, it's that simple. In the next section, what we'll do is we're going to go back to the calibrate function. We're going to show you how to save even a little bit more time if you have the touch probe. I can use the touch probe to find that Z0 and then come over and touch the tool setter, and then it'll know the difference between Z0 to here without having to use my tool to do any sort of touch offs to find Z0. So with that said, thanks for watching this section. All right, so in this section, I'm going to show you guys how to perform the calibrate function on the tool setter. This time though, we're going to use the touch probe if you have it. You'll find that it just basically makes the process a little bit quicker, and you can kind of combine steps when you put a new piece of stock in. Usually you're starting with the probe. Well, now you can start with the probe, come over and touch the tool setter straight away and do your calibrate kind of all in one sequence. So what I'm going to show you guys here is I've got the touch probe in the spindle. If you guys don't know how to use this, if you don't know how to use the routines I'm going through, you haven't set any of this up, please go back and watch our equivalent video tutorial on the touch probe and all of its routines. So this assumes that you already know how to use this. First thing I'm going to do, as always, just to be safe, I'm going to, since I am going to be using the touch probe and the tool setter, I just want to make sure that they both are plugged in and they're working. There's no electrical problems. I'm going to hit touch probe, this test button. You'll see it'll illuminate red. Then I'm just going to look down here at the status line in cut control, and with one hand, I'm going to hit the probe and make sure I see the text probe light up. As long as I'm getting that, I know we're working. Okay, then I'm going to do the same thing. We did this previously. We did this with the tool setter. Same deal, just come and touch this. You know, I know that I see tool set here. Okay, we know we're good to go. Now, what I'm really trying to do with calibrate is, before we use the tool, and I manually touch the tool off of here, I used a little piece of paper to find the surface using the tool. Not exactly the most accurate or best way to do this. So what we're going to do now is we're going to use the probe to come find our G54Z0, which is just the top of this surface here. And then, since the probe is already zeroed to here, I'm just going to come and touch the tool setter right after that. That way, now I can calibrate doing that maneuver, and I also get my G54Z0 set up here, so that when I put my first tool in, I can hit auto tool set and boom, hit it off of here, and now my first tool is ready to go. So with that said, for this, I need to find that top surface. So to just keep things simple, I'm going to use my Z-axis probing. This is just the single axis probing module routine, and what that's going to do is just move straight down in Z, and it's just going to find the top surface. Another routine I could use is the corner probing XYZ. What this does is, if I had a piece of stock, I could pick a corner and it's going to go and touch off in all 3 axes and then set that top corner to 0 in all axes. So you could use this, find Z0 that way, then come touch the tool setter. For now, to keep things simple, I'm just going to use the Z-axis probing. So what I'm going to do is I'm going to hit start routine and continue, and it should just touch off my part and find the top surface. So now what that did is it set the stylus to this surface right here. So I know that at least at this tip, if I were to jog it down to this surface here, I'd be reading Z0, which is what we want. Then the next thing, all I have to do now is come to my tool setter module. I'm going to hit the calibrate, but before I do, I'm going to hit this button and select probe. Now I know that I'm using the probe to do the calibration move, and what this is going to do is it's going to, the controller is going to look at both of these now simultaneously, and whatever one triggers first, that's the trigger point, and that's what it's going to use to do the calibrate. I can hit the calibrate button. It's going to do the sanity check that I'm in the right position with my tool setter. I'll say continue. Okay, looks like we touched off, and I got the calibration completed here, and now I've got my tool offset value calculated. So now I know the difference between here and the top of there, and now all I have to do is pull my touch probe out, pop a tool in, and hit auto tool set. I can now have my tool ready to go for that first operation. Thanks for watching.